Okay, here we go.
Some of the past tattoos around us, fire.
Oh, yeah.
Just like flame. Yeah.
Sounds like fun.
Larry had a
Oh, yeah.
Larry tree tattoo.
Yeah, they used to be them outside of I know what you have.
Okay, normal distribution. The whole rest of the semester is all about data that's normally distributed. And what does it mean to be normally distributed?
Not abnormal.
Not abnormal. The mean,
I can't write anymore.
median,
I lost my writing ability.
and mode are all approximately the same, approximately equal, which makes the graph symmetrical. Symmetrical. This first section is just pretty much all review, so we're probably going to do some of this and some of the next section.
I literally can't write.
So by symmetrical, we mean it has that nice bell shape. Heard of the bell curve before?
We talked about it.
Yep, bell curve, symmetrical. Because your mean, median, and mode are all lined up right on this line of symmetry. Mean, median, and mode are all right there. The area under the curve does add up to 1, because the area under the curve is going to represent probabilities. And probability distribution, remember the probabilities add up to 1? And the curve approaches. But never touches the x-axis. So we are going to be looking at data that's all symmetrical. Okay, yeah, you'll be drawing this curve a lot. Okay, what happens is, when you draw the top part, okay, that's called concave down, because it's the curve down, like an upside down cereal bowl. And what happens is, we hit a point here where the concavity switches, and now it becomes concave up. I mean, it's supposed to be a nice smooth transition there, but the concavity switches at this point. See how that's kind of curved up, like a side of a cereal bowl going normal way? And then the same thing here. That point where it switches, those are called inflection points. Inflection point. And that's where concavity switches.
Is there no X in inflection?
The C. Okay. And that inflection point happens exactly 1 standard deviation away from the mean. You remember doing this before? We went 3 standard deviations out. So if this is my mean, that inflection point happens 1 standard deviation up. So it's mean plus a standard deviation. This one, mean minus 1 standard deviation. That's where your inflection point is happening. Okay, what does standard deviation tell us about data again? Yeah, how spread out. The bigger the standard deviation, the wider this graph gets. The smaller the standard deviation, the narrower it is. So that was a good question, Ashley. Standard deviation indicates how spread out the data are. How spread out the data are. So a small standard deviation, narrow graph.
Yeah, it's not the data R.
Indicates how spread out the data are. I know I always end sentences with verbs and you can't do it, but how do you rewrite that?
How spread out the data is.
Data's plural, I know that.
But that's weird. Because of the word. Spanish has the same thing. Sometimes you have yeah. That doesn't mean that you should start. You do like.
Oh my God, it was so dry.
I know my matching is right because it's plural, but I don't usually don't end sentences that way.
It can be rough, but I'm still writing it like it. Because it sounds weird.
Okay, so a small standard deviation gives you a narrow graph, big standard deviation gives you a wide graph. Example 1 then. I'm going to give you 3 graphs, all on the same axis. Tall, skinny graph. 3 or 4.
In 6 weeks.
Mm-hmm.
Wait, what?
These chapters run real quick.
Oh.
Real quick.
Because they did.
What do we do in the junior and the senior? Do
Keep
we
going.
actually learn anything?
Yep.
Oh. Do we just because the seniors don't need to know that information? They're good. No, look at how angled it is.
Oh, it's like.
I have her. It's in italics. My bill is in italics. Whoa, what is that?
It's my 3rd graph. Oh, yeah. We'll go A, B, and C.
I thought we were just doing one. Should have written that in there. This looks really ugly.
Okay. Can you tell me what the means are on these 3 graphs? Or what I tried to shoot for. The mean of A is 45. I was shooting for B to be 45, so they have the same mean, and C is at 60. So the mean tells you where that line of symmetry is at. Now standard deviations, you can't tell me what the numbers are, but you should be able to put them in order. Which one has the biggest standard deviation, which one has the smallest, and which one's in the middle. So which graph has the biggest standard deviation? B. Why B? The widest. So B has the biggest. Does that make sense, Ashley?
Oh, I didn't even label them.
Oh, that would be helpful.
Yeah.
Which one has the smallest standard deviation? C. Why? The narrowest. All we're looking at is width here. So C is the smallest. And A is going to be somewhere in between the A and B standard deviations.
Call it middle.
Middle. So the only point I want you to get here is that the line of symmetry is your mean, and then how wide it is the standard deviation indicating that. You can do that? Okay. Can I get rid of this? Okay. The empirical rule. We had the empirical rule back in chapter 3, I believe.
My brother. I never understood these.
Okay, it approximates the area under the curve. That's our 68, 95, 99.7 rule. Okay, make this graph kind of big so you can put your percentages in it. If data is normally distributed, it will fall into a graph that looks like this. Always. That's what normal distribution means. And what it's telling me is if I go out 3 standard deviations above the mean and 3 standard deviations below the mean, that will contain 99.7% of my data. Is there data beyond that? Yes, just very little. So kind of just estimate, well, the third one, and these are all evenly spaced, kind of hits right where it starts to get really close to the x-axis. Or where your inflection point is at. They're all evenly spaced. It's a number line. So if you didn't get empirical rule before, you got to get it now. Okay. And what these divisions are is they're adding on 1 standard deviation. So this point here will be the mean plus 1 standard deviation. This one will be the mean plus 2 standard deviations. And then the mean plus 3 standard deviations. And then obviously we go below, we subtract the standard deviation. So this one that's below is the mean minus 1 standard deviation. Mean minus 2 standard deviations. And mean minus 3 standard deviations. Okay, where do these percentages come into play? 68% of the data, if it's normally distributed, will be within 1 standard deviation of the mean. What does it mean to be within 1 standard deviation of the mean? Above or below, within 1. So in these two chunks, between these two values, that will house 68% of your data. And because it's symmetrical, how much is going to be in each chunk then? 34%. For a total of 68. 95% of your data is going to be within 2 standard deviations of the mean. That means these 4 pieces, the 2 above and the 2 below. So from here to here will contain 95% of your data. Well, if we do the math, you're going to have 13.5% in each one of these. That'd be 95 minus 68 divided evenly. And then how much of our data is going to be within 3 standard deviations of the mean? 99.7. And I did the math there. Each of these pieces are 2.35%. And that leaves 0.15% in the 2 tail pieces. That's 0.3% divided evenly. What? This one, I can fit it in my little space here, but